We're demonstrating transcutaneous auricular vagus nerve stimulation today, also known in short as taVNS. taVNS is a really promising replacement for cervically implanted conventional vagus nerve stimulation. It's a really exciting new form of neuromodulation. Because taVNS is safe and non-invasive, it can extend its reach to a broad range of neuropsychiatric and human performance applications.
The procedure is pretty straightforward, but the software for delivering stimulation and determining perceptual threshold needs careful consideration. We're providing our software so that other researchers don't have to reinvent the wheel.
As demonstrated in this video, proper protocol and equipment is integral for reproducible results.
Begin by seating the participant in a relaxed position with the legs elevated and the head supported. Inspect the left ear of the participant, confirming that no jewelry is attached, that all makeup and lotion are removed, and that there are no skin-related contraindications at the site of stimulation. Find the anterior wall of the outer ear canal, landmarked by the tragus, to locate the stimulation target. Alternative sites like the Simba concha may be explored as alternative active targets. Then use an alcohol prep pad to gently scrub the target site, both internally and externally, to decrease the skin resistance and to increase the conductance. Before placing the electrodes, visually inspect the materials to confirm that a clean, corrosion-free surface is exposed before disinfecting the electrodes to prevent the spread of bacteria between participants. Next, use a narrow wooden applicator to spread a less than 1 mm layer of conductive paste evenly across the surface of each electrode. And connect the electrode cables to the stimulation device in the off mode. After verifying the polarity of the electrodes, clip the spring electrode onto the tragus with the anode contacting the anterior wall of the outer ear canal, and the cathode contacting the anterior region of the tragus. Then confirm that the participant is comfortable, and that the regional blood flow has not been disrupted by asking participant if they are okay. To determine the perceptual threshold, turn on the stimulator and set the output to 3 milliamps. Deliver a 1-second train of transcutaneous auricular vagus nerve stimulation, or taVNS, at the appropriate experimental pulse width and frequency. Ask the participant whether they felt the stimulation. The sensation is typically reported as a tickle or pricking sensation. If the answer is yes, turn down stimulation intensity by 50% and repeat the stimulation. Repeat stimulation until a minimum of 4 yes responses are achieved, for which the 4th yes response comes after a no. The perceptual threshold intensity is the value at which the participant gives the 4th yes. Once the perceptual threshold has been determined, use a computer running a pulse-generating graphic user interface connected to a data acquisition unit to drive the stimulation system. The software should output transistor-transistor logic, or TTL, pulses as programmable settings. Set the stimulation to be delivered at 200% of the perceptual threshold, and set the guidelines for the duty cycles as appropriate for conducting a long stimulation session. The length of the total stimulation session time should be varied between sessions. After the stimulation, record the objective data regarding the participant's stimulation discomfort and side effects on a scale from 0 to 10. Remove the stimulation electrode from the participant's ear, and use an alcohol prep pad to clean the residual conductive paste. Immediately upon removal, disinfect the stimulation electrode with alcohol, and inspect the ear for redness or irritation at the stimulation site. When proper skin preparation is conducted, the perceptual threshold decreases as the pulse width increases. Initial studies exploring the effect of the pulse width on the perceptual threshold in healthy individuals determined that a constant current stimulator with a capacity of delivering up to 5 milliamps of current is required for a stimulation of 500 microsecond pulse width parameters, and that a minimum of a 10 milliamp stimulator is required for lower pulse widths. Further, the biologically active pulse width of 500 microseconds delivered at 25 Hz is reported on average to a pain rating of just about 2, similar to that reported for sham stimulations.
taVNS has a broad parameter space, and it is important to consider parameters like pulse width, frequency, and duty cycle to optimize the behavioral benefits of your particular application.
This can become a widely used tool in medicine and neuroscience. The vagus nerve is a complex nerve bundle with numerous tunable responses.
You can combine taVNS with fMRI, EEG, and other physiological recordings to measure the central, peripheral, or other effects of stimulation.